Oh, I don't know if I want to roll today. Feels like a lot of work today. Should we call on people like old school? Have you guys call on the next person? Oh, this is still a no. Don't even want to answer today, huh? We're we're only on the second day. Tomorrow's the hardest day. Today is the middle day. Okay. Well, let's. First thing we need to do is find the derivative. That is not the marker. Okay, so f prime of x is going to be 2/3 x squared minus 4 to the negative 1/3 times 2x. All right. Before we start the problem, should we try to figure out if there's any numbers that are not possible in the original function? Because that's traditionally a good idea. But now that I'm saying that out loud, you can have cube root of positive and negative, so that wouldn't affect anything. The 2 on the top is squared, and when you square the inside number, you can, every number is a possible choice. Like, you wouldn't get any answers that are undefined. If this was an even root on the bottom, well, then we'd probably have to pause and try to figure out if we'd end up with a negative root. But cube roots are good. Okay, so my derivative, I traditionally will want to try to write it as numerator and denominator if I can. So I've got the 2 on the top, I've got the 2x on the top, so that would give me 4x on the top. I've got a 3 on the bottom, and I've got a cube root on the bottom. So 3 cube root, that's a 3. We'll just pretend it is. I can't write that small. Good enough. Okay, now I'm looking for zeros and undefines. Part of the reason you want to write it as a fraction, if you can, is because that's an easy way to identify zeros and undefines. Any number that makes the bottom equal to 0 is undefined values. Any number that makes the top equal to 0 is a 0. So I'm basically going to solve the top and bottom separate. That's kind of why a fraction is nice to have. Okay, so top, if I set that equal to 0, would give me x equals 0. The bottom, what number would make that equal to 0? Looks like plus and minus 2. So x cannot be plus and minus 2. That's just kind of one quick way to identify zeros and not allowads. Okay, but those are our 3 critical. Oh, shoot. I just forgot. I definitely wanted to call on somebody for that. It's kind of late now, but I guess we can still do it. Fiona, let's pick a number, since you're the expert, and you got to back them up. 18. Patrick, what's a critical value / critical number?
A number that's like 0 or undefined, or when the derivative is 0 or undefined.
Perfect. It's when the derivative is equal to 0 or undefined. Okay, nice. So that's what we just found. I'm going to take my critical numbers and put them on a number line. You could put them in a table if you would like. I don't know if any of you had a chance to look at the way it was set up with a table in the packet. Okay, but I'm going to do a number line. And 3 critical numbers means I'm going to have 4 sections. Okay, so this is going to be x equals -2, x equals 0, x equals +2. This is going to be negative infinity to -2. -2 to 0. And after a while, FYI, if you just get used to these intervals, you don't necessarily have to write them on the top. Since this isn't officially graded on the AP test, it doesn't matter how you write it. Okay, so I got 4 intervals. I'm going to need to test a number from each interval to check if the derivative is positive or negative. Okay, so let me test. Yeah, I'll just do -10 again. It would make the top of my fraction positive. Oh, okay, negative. It would make the bottom of my fraction, see, that would make this positive, positive, positive. So I would have a negative top, positive bottom. My derivative would be negative. That was for the first section. Okay, second section. I would assume every single person in here would test -1. Otherwise, you'd have to use a decimal. So -1, 4 times -1 is -4, so that's a negative top. -1 squared minus 4 is negative. So the cube root of a negative is negative, times 3 would be negative. So that gives me a positive answer. So my derivative in this section is positive. +1, that would be a positive top, negative bottom. That would give me a negative section. Are you guys okay knowing where I'm writing these minus and pluses down from? I know I kind of just jumped right into that. I'm basically just testing the number in the derivative to figure out if the derivative is positive or negative. Okay, so 10 would be positive on top. Did somebody say wait? Oh, did you figure it out? Okay. On bottom, also positive, so we have a positive portion over here. Did everybody get to leave class all of a sudden? How come we're not leaving? Okay, so a negative slope means this is decreasing. This section is increasing, decreasing, increasing. Okay, if I want to draw a visual sketch, I certainly can. Down, up, down, up. This doesn't mean my picture looks like a W. It just, that's roughly what the pieces do. Okay, so then that is going to tell me this is a relative max, relative min, at x equals -2, because it changes from decreasing to increasing. It will be a relative max at x equals 0. Relative min. And if I'm looking for intervals of increasing, decreasing, that's essentially what I just wrote down right here. How are we at this one? Did this one seem to go okay? Okay, the portion, oh, go ahead. Yep. Wait, repeat that last part. I didn't hear the actual question you said.
Repeat how you solve for the x equals, or x doesn't equal +or -2.
Oh, sure. I didn't write any of it down. I basically did it in my head. If I have 3 cube root x squared minus 4, if I want to find where numbers I cannot use, I set it equal to 0, or I can say does not equal 0, however you want to write that. And then I would solve this. So I would divide by 3, cube both sides, and then I would have x squared minus 4 cannot equal 0, and then add 4 square root. So I basically solve it just like I solved for a 0 on the top. Yeah.
So for the first increasing that you got at x equals negative sign,
Yep.
how would it be negative on the top?
So negative 1 squared would be 1. 1 minus 4 would be negative 3. And then the cube root of a negative would stay negative. So I don't know what the actual answer is, but I know it's negative. Yep. Okay, this one's a little bit harder. If I were to actually graph this, my guess is this has like a sharp point at some of these spots. Actually, I shouldn't even guess. It's got a slope of 0 in the middle, and it's got a sharp point at both of these spots. Yeah. Maybe it would be a W with sharp corners on the bottom. Do you guys feel like you can tackle this one? Okay. The most difficult part about this question is going to be the derivative, trying to find the zeros and undefines. So maybe just see if you can get that far on your own, and we'll all do that part together. And then I'll, once we go over that part together, you could finish it with the number line table part. So see if you can find the derivative and find any critical values. Sure. When you come back, do you want to shut the door?
Oh, yeah.
Bless you. The part that you may be stuck on is when you do the product rule, frequently you're going to have like factors. And for our purposes, if we have to solve the derivative, like find answers, having it in factored form is much easier than anything else. So first thing I did was I factored out x to the negative 1/3. And then the remaining stuff became the other factor. And it's not even written properly. Like, I'd probably get a slap on the hand if I wrote this as an answer, right? You can't have a fraction in the top of a fraction, but I really didn't care because I was just finding answers from it. I wasn't trying to present it or something. So the top of the fraction was the 1 factor, and that gave me an answer of 4/5. The factor that I had factored out, x to the negative 1/3, I moved to the bottom. Now, you guys should be kind of used to this at this point because we've done it a handful of times now. Do you guys want me to explain the negative 1/3 up front?
Well, why don't you just distribute the x to the 2/3 to the x minus 2? And then you can just,
Yeah, you could. I'm not going to because that doesn't always work out. That would basically be a chancing it to see if it works. Factoring something out will always work for what we need it for. So distributing it out isn't wrong in any which way. And if you can find answers and solutions, that's fine. But frequently you're not going to be able to. So the factoring out method will always get you solutions. Did you guys get these 2 answers on your own? Oh boy. Okay. Well, at least I got some verification on a little bit. Go ahead and ask on the part that you would have been stuck on. The whole purpose of this is to try to help you out so that you can do it on your own, right? Yeah.
Can you just go through like how you got from the first step to the second step?
Sure. So I knew that there was a common factor of an x to a power. You guys this is how I do it in my head, okay? Let's say we have x to the 8th plus x to the 6th. You're just so used to doing that you would automatically know to factor out 6. But what you're doing is you're picking the smallest of the 2 numbers. And you factor out the smaller power. The power that's going to be left right here, you get by taking the original power minus what you took out. You're so used to it that the numbers are easy that you immediately know it's a 2. But that's where it comes from. So over here, negative 1/3 is the smaller of the 2 numbers. So that's why I took that out. And then the original power was 2/3, and I would subtract negative 1/3, which gives me x to the 1st, which I didn't write first power. And then over here, this entire thing was gone, factored out. So I was left with 2/3 times x minus 2, which I just kind of multiplied out. I don't know if that helps. That's kind of how I tried visualizing it. But this is the method that I do all the time. I'm a little worried that some of you are just too scared to answer any kind of questions because you feel like you're going to look dumb or something. It's okay. Yeah, go ahead.
That's subtraction sign in front of the 4/3 of that.
Correct.
Okay.
Yeah, my times and subtraction don't always look much different. I distributed the 2/3 times x minus 2. If you guys are okay with this information that's here, then why don't you try to do the number line portion on the right-hand side? That would find you relative extrema and intervals of increasing, decreasing. Probably the hardest thing for you is most likely doing a test number from 0 to 4/5. There's different ways you can do it. I mean, like, I know you have your calculator with you too. They're intended for non-calculator, but it's kind of weird, so I get it.
Are we using the calculator on the next test?
No, unfortunately. It's kind of one thing I dislike is a lot of the calculator stuff comes up like big time towards the end in like 8 especially. And I would prefer you guys to have chances to use them a lot before then so you get more comfortable with it. But it's kind of like this entire topic is meant for non-calculators, so it's almost like we have a lot of non-calculator specific things. But I also want you guys to get practice at using the calculator so you're used to it on the test. So we'll try to fit it in when we can, I guess. Do you guys want me to do another example? There basically is only one other type, and it's rational ones. I think we get it done at 10:30, right? 10:29, I mean. Yeah, we could probably fit that in. So rationals is the last style. And then if we're able to get this done today, then that should leave us actually all tomorrow to work to get everything done where I can help you with this stuff in class. Seem like an okay plan? Okay, let's do that then. So rationals frequently have vertical asymptotes. And vertical asymptotes kind of throw a plan or a wrench in like this. And the reason is because vertical asymptotes are often going to be a critical number, but you can't actually have the original graph there. So vertical asymptotes cannot be maxes or mins, even though when we do the work on the table, it's going to look like they are. So the hardest part for you is going to be just remembering, that it's a vertical asymptote, that it can't have answers there. It's a critical number because something happens there, but you won't get any types of answers. So we've got our original function. We're going to have to do the derivative, which unfortunately means quotient rule. You're having troubles over there. FYI, I like the bow tie. That was pretty good. That was a pretty good move. So what do we have? We have x minus 2, g f prime. So 2x minus f g prime over g squared numerator looks like junk. Nothing can be done. So it looks like the numerator, I'm just going to have to put it together because nothing factors out. So 2x squared minus x squared would be x squared minus 4x. That's going to be the only x. Plus 3. Oh, that actually works because it factors. But that's bad because that means we're going to have a lot of answers. So our zeros come from the top, undefineds from the bottom. So x cannot be 2. The top factors into minus 3, minus 1. So that would give me 1 and 3. And I have no idea what this graph looks like, so. So our derivative gives us 3 critical numbers. Something happens at 3 different places. And like I said before we started this, the important thing is to remember that 2 cannot be anything because it's a vertical asymptote in the original problem. So when we start making our table, 2 is a critical number, but nothing can actually take place there. Are we okay with the derivative and answers from it? Like, does anybody want me to explain parts of that before I go on? I don't want to like fly through it, I guess. I'm guessing you guys are pretty used to the quotient rule by now. Maybe you haven't used it for a while though. Yeah.
What were you saying about vertical asymptotes? What are they asymptotes?
So a vertical asymptote is a critical number. Almost always it ends up being. And when we make our table, it's going to look like a relative max or a relative min. But there's actually nothing there in the original function, so it can't be a relative max or min, even though it's going to look like it table-wise. So if I make my number line, what are we going to, negative infinity to 1, 1 to 2, oh, this is going to be annoying, 2 to 3. Our test numbers are not going to be good. So I will test negative 10. And that would give me 100 minus, that doesn't matter. It'll be positive on top. Squared on the, oh, the bottom is squared, so that's always going to be positive. I don't even have to worry about testing the bottom. You know what? I'm going to write my factors. I'm going to write it in factored form because that's easier to test. That's easier to test numbers. Okay, let's test 1.5. 1.5 minus 1 would be positive. 1.5 minus 3 would be negative, so the top is negative. The bottom is always going to be positive. 2.5 will give me the exact same thing. Yeah. And then 10 will give me positive, positive. So this one actually works out kind of weird. We've got increasing, decreasing, decreasing, increasing. Now, me personally, what I do is kind of stupid, but it works for me. If I know this is a vertical asymptote, I'm going to draw a dotted line there so that I cannot write an answer of relative max or min. So it's dumb. But if it works, it technically isn't dumb. Increasing to decreasing would be a relative max. Decreasing to increasing, relative min. I'm trying to picture what this looks like in my head, but so it's kind of like a weird distorted upside down parabola on the left of the asymptote, and then a weird distorted parabola on the right. This is probably a hyperbola, where it's not really a parabola, but it's like a V-looking one. It's probably got a slant asymptote. Oh yeah, it definitely does. This will have a slant asymptote of X. Okay, but anyway, I just wanted to make sure that you guys knew the vertical asymptotes throw off your answers at the end. It is not done any direction different, whatever, but it just makes your answers slightly different. A critical number doesn't have to be a max or min, but it can be. Okay. We got 3 of them done today. I'm pretty impressed. Go ahead.
So for x equals 2, you could just say vertical asymptote.
Say it again.
So when you're writing your final answer, would you say vertical asymptote at x equals 2?
Nope. So you're asked to find relative extrema, and you would just answer that there's 2 of them. One at a relative max at 1, relative min at 3. And then if asked you for increasing, decreasing intervals, you'd give them. You basically only answer what's being asked for. If somebody asked if there was a vertical asymptote, you could answer that, but We won't need to specifically say it's that. Okay, we have, is this good or bad? Did I go through these way too fast today? I bet you it just went a lot faster because I didn't call on people's. Because that goes really slow. I also like calling on you though, because then I get an idea of how well you know this. So, okay. Well, I can help you guys with whatever time we have today. And then tomorrow we'll make a tentative plan of just working through the hour. And then I'll try to set up something for reviewing on Thursday. And Friday's gonna be a mess of a day anyway, but whatever.